DNA is the instruction to build an organism, but it doesn't perform the actions to actually build it. If DNA is the instruction, then RNA, aka ribonucleic acid, is the minion that uses this instruction to carry out certain projects. There are some main differences between DNA and RNA. First, DNA nucleotides and RNA nucleotides have different bases. While the bases for a DNA nucleotide are ATGC, the bases for an RNA nucleotide are AUGC, with U replacing T by pairing up with A. Along with that, DNA has the shape of a double helix, meaning it has two twisted strands. RNA has only one strand. RNA is created by copying a sequence of nucleotides from a DNA strand. This process, initiated by a gene of DNA called a promoter, takes place in the nucleus and is called transcription. Transcription is a necessary process for proteins to be made because without the making of the RNA, nothing would essentially function, as the DNA cannot perform any of the jobs to make protein. RNA polymerase is an enzyme that helps perform transcription. The main job of the polymerase is to unwind the DNA strands and copy one of the strands into RNA. It goes along the DNA strand in the direction of 5' cap to the 3' tail. The strand is called the DNA template strand. While going along the DNA template strand, the polymerase starts to copy the DNA at the TATA box. This is an area of a sequence of code that begins with TATAAAA, allowing the enzyme to know where to begin. The polymerase creates a complementary strand of that DNA segment with this copied code. This is called the elongation of RNA. At one point, while the polymerase is copying the DNA, the RNA and DNA template strands are connected to each other. They disconnect and the DNA winds back. This connection is called the DNA-RNA hybrid complex. This DNA segment becomes one of the three main types of RNA. It is called messenger RNA, or mRNA. Once the mRNA has its desired length of DNA code, the polymerase terminates, making the making of RNA. Currently, these strands of RNA are called pmRNA, or pre-RNA. Before pmRNA can become mRNA and travel out to the ribosomes, the pmRNA needs to remove unwanted DNA codes in its strand. These unwanted codes are called introns. Introns are not useful and do not have code that relates to the making of the protein. Their opposite, exons, are codes that help create the protein by matching with amino acids. Once these introns are removed, the strands fully become mRNA. mRNA's main job is to carry the DNA segment out of the nucleus into the cytoplasm where they come in contact with the ribosome. Once the nRNA reaches the ribosome, which is made out of the second type of RNA, ribosomal RNA or rRNA, it enters and translation begins. Translation, which occurs in the ribosome, is the process of using the mRNA's message to build protein with the help of transfer RNA, the third type of RNA, also known as tRNA. While the mRNA is in the ribosome, the tRNA are trying to match up with the mRNA's code. Each tRNA holds and amino acids create peptide bonds. As more tRNAs are brought together, the protein chain becomes larger as more amino acids are added on. This process is called the elongation of amino acids. The way these amino acids are brought together are through A site, P site, and E site. The A site is when the tRNA goes to its complementary mRNA placement. The P site is when the amino acid bonds with its neighboring amino acid. The E site, the final step, is where the tRNA finally leaves its job being done. The way codes are read for mRNA and tRNA is by separating them into groups of three. For mRNA, these groups are called codons. For tRNA, these are known as anticodons. A start codon is a codon that initiates translation and is the catalyst for the codes to be read. Mutations can occur when a code is copied incorrectly due to the way that tRNA reads the mRNA. One mutation can cause a chain reaction of incorrect combinations of amino acids. If these mutations are detected in time, physical defects can occur. After these steps occur, a protein is finally made to regulate and complete bodily functions. It is important to note that these steps are repeated over and over until death. And that is finally the end of transcription and translation with Rhea and Tolu. Bye!